Hello, welcome back to the channel. Welcome back to the video series where I am providing a high-level overview of the site planning and design handbook. This video is about chapter 5, and chapter 5 is um, design for people. So let's get started. We know that the human scale of site design is a primary interest for site developers, and site designs reflect the values of the society at that time through the work of designers. For example, the ideal city, a painting by Piero della Francesca, reflects the values of the Renaissance: civic order, intellect, and beauty as found in the works of society. The ideal city is presented on a flat plain, its avenues uninterrupted by inconvenient topography or natural features. With the exception of a few clouds in the sky, nature is completely absent. So modern sensibilities have moved beyond the mythology of Francesca's imaginary city, and we have started to embrace nature in our planning and design. Sites often support multiple uses and users with different needs and expectations, and accommodating those needs and expectations has led to a variety of approaches to design. Universal design principles have become more widely recognized and accepted in recent years. These principles go beyond site and building concerns to include product and industrial design. In essence, the precepts of universal design are intended to provide equity and simplicity in access and use of all products of design. A site design using these precepts avoids segregating one set of users from another whenever possible. Multiple but equal points of access to accommodate people with accessibility issues are planned to avoid stigmatizing some users. Signage is designed to be useful regarding of one's language. Understanding the limitations of site users who range from toddlers to the elderly requires more than one common human factors and range of motion charts established for the average person. So when we talk about general site design guidelines for pedestrians, we need to understand that virtually all of the furnishings comply with the accepted standards of human dimensions. However, it remains the responsibility of the design professional to select and specify the materials appropriate to the site. A working knowledge of human dimensions and behavior is necessary. So please refer back to the textbook. You can see the standing and walking dimensions of a person, as well as chair and table dimensions and wheelchair use dimensions. So that is critically important to develop the accessible design. And you can see the wheelchair 180-degree turn, as well as the um, pathway design parameters. So when we design pedestrian walkways, the peak time for walking is midday, counter-cyclical to vehicle traffic, and sidewalks should be designed to account for this peak time. Many localities have predetermined minimum standards for sidewalk development in residential areas, but do not provide guidance for commercial sites or other circumstances where minimums are not adequate. The sidewalk width must provide the level of service suited to the user. The parameters of sidewalk width are the anticipated volume of foot traffic, how quickly pedestrians will be walking, and the desired density of traffic. The width can be determined using the following method. Um, so the width of the pathway or sidewalk equals to, that's the W, that equals VM divided by S. So where V is the volume in person per minute. M is the space module or square feet allowed per person, and S is the walking speed in feet per minute. So please refer back to the textbook and you can see how that is solved. So walking speeds vary greatly among people, but an average walking speed of 4 foot per second is usually assumed. A number of factors influence this speed, and the needs of particular users should be considered. The very young and older people walk slower than the average speed, and people tend to walk faster in the middle of a block and slow down at intersections. The activity people are engaged in affects walking speed as well. For example, shoppers walk slower than commuters, men tend to walk faster than women, and groups of people walk slower than a lone individual. Curbs, islands, pathways, changes in grade, and even ramps can present barriers of one sort to another or another to users. Grade also affect walking speed, level of service, and safety. Sidewalks should be designed with a minimum cross slope of 1% to allow for drainage, but the cross slope should not exceed 3%. A longitudinal slope of up to 3% is desirable, but slopes greater than 5% should be avoided in areas where freezing may be an issue. And you can see here there are levels of service for sidewalks. There is a chart here in the textbook, so you can refer to that. Also, there is another chart showing design considerations for outdoor stairways. So that is important for your design decisions as well. So when incorporating stairs into an outdoor design, local standards often need to be considered. And also here you can see the diagram showing usable tread with an acceptable nosing and flush riser. So please refer to those dimensions. Ramps should be designed to meet the following ADA requirements. Ramps with a slope 1/12 and 1/16 should be designed to not exceed a rise of 30 inches or a run of 30 feet. Flatter ramps of 1/16 to 1/20 may be designed to a run of 40 feet, but the maximum rise should not exceed 30 inches. The minimum clear width of a ramp is 36 inches. Ramps shall have level landings at the bottom and top of each ramp and each ramp run. The cross slope of ramp surfaces shall not be greater than 1/50. Outdoor ramps and their approaches shall be designed so that water will not accumulate on walking surfaces. Landings shall be at least as wide as the ramp run leading to it and a minimum of 60 inches clear. If the ramp changes direction at landings, the minimum landing size is 60 by 60 inches. If a ramp run has a rise greater than 6 inches, a horizontal projection greater than 72 inches, then it shall have uh, a uh, excuse me, then that ramp should definitely have a different dimension, and should have handrails on both sides. Excuse me. Handrails are not required on curb ramps. So designers may need to consider other factors such as the number of people using the ramp and the trend toward larger personal mobility vehicles. Handrails should be continuous along both sides of ramp segments. The inside handrail on switchback on dogleg ramps should always be continuous. If handrails are not continuous, they shall extend at least 12 inches beyond the top and bottom of the ramp segment and shall be parallel with the floor or ground surface. The clear space between the handrail and the wall shall be 1.5 inches Top of handrail gripping surfaces shall be mounted between 34 and 38 inches above ramp surfaces. Handrails should not rotate within their fittings. The ADA, or the with Disabilities Act, requires that reasonable accommodations be made for those among us with physical limitations or disabilities. Standard practices have been developed to facilitate these accommodations and are broadly followed today. In addition to the standards of sidewalk design, we should be aware of the quality of the sidewalk itself. When designing a quality sidewalk, it may be necessary to go beyond the standards and consider how the sidewalk best meets the designs of the various users. Sidewalks are a more intimate space than streets and parking lots where we move enclosed in a vehicle. A high quality sidewalk creates a human oriented space for interaction, movement, commerce, relaxation, and perhaps vegetation. And it does this in a manner that is safe. So please refer to the chart here. It is the ADA site survey. So you can see here are a few questions asked, such as are an adequate number of accessible parking places designated? Are accessible spaces marked using the international symbol of accessibility? And so on. So please refer to that so you can use that when you design the sidewalks. Let's talk about paving materials and design. The choice of paving materials is broad and generally is determined by the nature of the project and the preferences of the designer and the client. Areas of concerns for paving include installation and life cycle costs, durability, slip resistance, and appearance. Brick and pavers for pathways and sidewalk paving are described in ASTM C902 by grades and type. So type 1 brick is recommended for high traffic areas such as driveways or entranceways. Type 2 is used on walkways and other areas of moderate traffic. And type 3 is used in areas where low level of traffic are anticipated, such as patios. And here is another chart showing the materials for pathway and sidewalk paving. So there are different types of materials, and you can see material characteristics and qualifiers. So for example, granite, limestone, sandstone, flagstone, slate, then brick and a few types of bricks such as SX grade, MX grade, NX grade, and then asphalt and concrete. So you can see that here. Also, there is a section showing paver installation detail, and you can see brick bonds and patterns. So you definitely need to see that because saying and just kind of like naming those bonds will not give you any idea of how that looks. So if I say there are like stacked bond, running bond, herringbone, basket weave, and basket weave variation. So that's not going to tell you anything. So please back up my videos with the textbook and you will see those images and you will remember them. Also, there is another section showing typical asphalt pavement for a pathway. That's light duty. And you can see also typical concrete pavement for a sidewalk. Let's talk about pervious paving. Pervious or permeable paving is an important alternative to traditional paving systems, and LEED certification actually requires that, and the pervious paving system may contribute to the points of LEED certification. So the advantage of porous paving is the ready flow of stormwater to the substrate and underlying soil. Care should be taken to be certain the substrate and soil have the capacity to absorb the water they will receive. Rooftops and other impermeable surfaces may increase the amount of stormwater flowing to the pervious paving. If the subsurface is unable to absorb the water, unwanted accumulation and saturation of the paving may occur. This can be a particular concern where freeze-thaw cycles occur, and it may be necessary to provide a storage volume below the porous paving system. This could require a design substrate of 24 to 36 inches, perhaps more in areas with high clay content soils. Um, so let's talk about signage. Designing signs is a specialty itself, and sometimes it requires a special permit, and many types of signs are available commercially. For common signs identifying designated handicap parking or restroom facilities, it's best to rely on signs that are familiar and in common use. The key elements for signs are readability and effective reading distance. To determine readability, it's necessary to understand the purpose of the sign. Signs providing direction or those meant to draw attention from a distance require larger lettering than signs describing a display or vista immediately before the viewer. So here is another chart showing effective reading distance and letter size. There's nothing to remember or memorize, but please know where to find that information. So, signs that use symbols to convey information, such as warnings or directions, are preferred over those that have information in only one language. Likewise, consideration should be given to ADA concerns when designing signage. If the information conveyed on the sign is necessary for access to be provided, textual signs should be installed with the signs. The familiar universal symbols have made sign selection for many purposes much easier. Let's talk about open space requirements. So, it is common practice today for developers to provide open space and recreation facilities as part of residential projects. As often as not, these elements are required by local ordinance. However, many communities do not have a coordinated or planned approach to these requirements, and the effect of the ordinance may be to create pockets of playground equipment or open space unrelated and unconnected to the development or to the community at large. So, without a comprehensive plan, a community may miss opportunities to serve its citizens with the best and most appropriate use and type of open space. Recreation and open space must be planned with regard to the projected users, the physical space, and the capability of a management entity to maintain the facility when it's constructed. These considerations must be measured in the short and long term, and new facilities should be planned to work in conjunction with existing facilities. Um, Active open space must be compatible with the site as well as with the user. An analysis of the site must include existing features such as watercourses, tree masses, topography, adjacent land uses, and areas of historic significance. These concerns, which might otherwise restrict development, may be effectively coordinated with the open space and recreation elements of the design. Many studies have been done to determine the leisure activities of various age groups and communities, and these studies have a shelf life, so they are applicable to a particular population. The size of facilities is also very important. The proposed active open space must be large enough to serve the user population, but remain within the scope of the responsible party's ability to maintain the facility again. And today's user um, demands projected life of 10 or 20 years of a facility. That is the minimum. So active and passive open space should be balanced. All age groups have a desire and an interest in both types of facility. Passive activities include reading, picnicking, sightseeing, photography, people watching, and strolling, as opposed to walking for exercise. And space for passive activities include unimproved open space, parkland, and wildlife habitat. But it can also include space on the fringes of activity areas that allow or even encourage people watching and observation. So again, please review the textbook. There is a chart showing percentage of population participating in recreation activities, as well as the activity days by age group. And that's interesting to see actually between 5 and 9, there are 205 active days per year. Between 10 and 19, it's 255. Then 20 to 29, it's 149. Between 30 and 44, there are 99. Then 45 to 64, it's 55 days per year. And 65 and over are just 15. So also, there is a chart showing activities or facilities in order of demand. And there is another chart showing community open space development standards. So that includes the playground or park, and then golf or soccer or other sports. So you can see the space required, area required, and facilities and population ratio. So also there is another charts showing different field sizes. Please refer to that if you are designing some sports facilities. There's a volleyball, lacrosse field, then soccer field. You can see the dimensions. Outdoor basketball court. Also you can see the accessibility and open space here. And please, let's take a look at that. The enactment of the ADA has served to increase our awareness of barriers to access to open space and the need to remove or overcome them. Today, plans must accommodate the entire population to a reasonable extent. Parks are specifically identified in the Act as a public accommodation that must respond to different groups and to the must be compliant with the minimum requirements of the ADA. And existing facilities are also subject to reasonable accommodation test. Here there is another chart showing the uh, baseball field and the access to the field. So the design and construction industry have been building new construction with a greater freedom of access for more than 20 years, but the ADA extends the requirements to provide access to existing parks and recreation facilities. So there is another chart showing, another diagram showing subsurface drainage detail, as well as artificial turf detail, and some of the pictures here. Another large chart that you would like to actually make yourself familiar with is the area requirements for community facilities if you're designing those spaces. So the physical characteristics of a site must also influence the degree of accessibility and the methods of providing accessibility. The quality of facilities and the quality of experience should be considered in any design or evaluation. The National Center for a Barrier-Free Environment suggests a systematic or staged approval to maximize the quality of the facility and the program. Parks and open spaces that provide varying degrees of access and challenge allow individuals to pursue their own limits of interest and ability. The range of accessibility offers an escalating scale of challenge, but provides for a maximum range of access. Another great chart showing suggested stages of accessibility. So there are three of them. And stage one provides access to all buildings, secondary facilities, and programs. Stage two, in addition to all of stage one, access is provided to unique opportunities or features. And stage three is, in addition to stages one and two, various degrees of access and challenge are provided to secondary opportunities or facilities. Also, phased integrated access is shown here as a map. Uh, Also, there are pictures of the accessibility design, accessible design. Let's move to the playground design. So, play areas and playgrounds should provide a variety of play equipment with special areas for different age groups and activities. The design should provide for shade and sunny areas, places for quiet activity and observation, as well as the play facility. The U.S. Consumer Product Safety Commission estimates 100,000 children are treated at hospital emergency rooms for injuries suffered at playgrounds, both private and public. Most of these children are between 5 and 10 years old. The majority of these injuries are related to design issues rather than supervision issues. The evaluation of existing playground equipment begins with the routine inspection at startup and throughout the season. Loose parts should be tightened and friction points lubricated. Ideally, the playground should not have direct street access and should be located at least several hundred feet from the street. Playgrounds should be sized on the basis of 70 square feet per child or 21 square foot per family. A 2,000 square foot playground for small children will serve about 100 families. Approximately 50 to 60% of the area should be turf. Equipment should be spaced to provide for safe and comfortable traffic flow. Minimum spacing is generally 12 feet between pieces of equipment. Placement and spacing of equipment should be avoid overlapping fall zones as well. So here another chart for the evaluation of playground equipment. So as the target age group of a playground moves from small children to children between 5 and 12 years old, there are some additional considerations. It is sometimes true that the play area for these older children includes a tot lot facility for younger children. The requirements for older children are developed around or in addition to the tot lot. Older children require larger surface or turf areas for participatory games and activities, and the shape and size of these areas deserves particular attention. So when we talk about playground surfacing, the choice of playground surface material is a critical factor in determining the injury impact of a fall. So the materials are selected for their shock absorbing ability, and also the height of a fall is the next most critical element of playground injury risk. The critical height is the approximate maximum height of a fall from which a life-threatening head injury would not be expected. Critical heights are determined by several different methods, including the standard specification for impact attenuation or surface systems under and around playground equipment. So there is a chart. You can see that the critical heights for selected playground equipment. Also, you can see the poured in place playground surface. And you can see playground surface showing a trip hazard. So that's from the playground assessment. Also fall zone for a slide. You can see the chart. So another chart showing fall zone for a multiple axis swing. And we are moving to the bicycle and multiple use paths. According to some reports, more than 30% of Americans ride bicycles for pleasure. As interest in bicycle has increased over the past 30 years, interest in bicycle paths and trails has increased as well. Communities across the country have developed or are planning to develop bicycle paths. Bicycle routes are usually one of three types: the dedicated bicycle path system separate from streets and automobile traffic, the designated lane system, and the road sharing system. So, bicycle routes require much the same level of planning and care as street design. Improper planning and installation can result in poor surface conditions and unsafe design. Uh, as with streets, an estimate of traffic volume is necessary. Unlike cars, there is little quantitative information or methods for estimating volume. In general, bicycle trips are one of three possible types: commuter trip, recreational trip, or neighborhood trip. And in Europe, we see way more bicycles. In some cities like Amsterdam are full of bicycles, and there are approximately 3 bicycles per person. So there are more bicycles than the population. So the another chart showing criteria for bicycle-friendly communities. Please take a look at that. Nothing to memorize, but it's always good to have that information available. Bike trails and pathways are commonly designed to serve pedestrians and other modes of recreation, such as rollerblades as well. Communicating the rules of the road for these sometimes conflicting uses is best done with clear signage and pavement marking where possible. Consideration should be given to installing wider riding surfaces on the steeper sections of routes with minimum travel lane width to allow passing. And we are moving to the next subsection of our chapter 5, and that's seating. So commercial sources for seating of all kinds are available, and the design professional's choice will be based on style, materials, durability, and availability of the bench or seating. A key concern is, of course, the comfort of the seat. Designers occasionally elect to design seating also. So side furniture is important for more than the convenience of passerbys. The type of seating helps define the area. Benches facing each other, for example, invite socialization and interaction, bringing more people to the common spaces. Seats near a playground or tot lot encourage adults to bring children and use the space. In turn, this increases surveillance of the play area. So there are a few images showing design with separate travel lanes for motor vehicles, pedestrians, and bicycles. Please refer to that. And we are moving to the accommodating an older population. The aging of the US population presents particular opportunities for site designers, and many firms specialize in designing places, especially for older folks. Accounting for the interests and needs of the older person in a design requires some understanding of the effects of aging on the individual. So, when designers work on the places for the older populations, there are a few things that we need to remember. So, aging is natural, and that process includes a number of physiological changes that influence an individual's ability to perform tasks and limit perception. These effects are present in different degrees in the individual who make up a community, but site planning and design professionals should be aware of the range of these normal changes in ability if they are to accommodate them effectively in site development. So the physiological changes of aging begin as early as 40 years old when the pupils of our eyes begin to shrink. This change continues for the rest of a person's life, slowly decreasing the amount of light entering the eyes and modifying the ability to see under low light conditions. The rule of thumb among clinicians is that the functions of systems and organs decline by as much as 50% by the time as one reached the age of 70. One perspective is that disease and disability are expected disruptions of life as we age. So, other physiological changes include a loss of elasticity in some tissues, including those of the chest wall. In turn, it requires more energy to breathe, and deep inhalation and exhalation are reduced, resulting in lower cardiac function and diminished oxygen levels in the blood. This results in a loss of muscle mass and a relative increase in the percentage of body fat in older people. So, um, also for the site planners and designers, mobility is a critical concern. There is some experience to suggest that manually operated mobility devices such as walkers and manual wheelchairs are responsible for more injuries than powered or power assisted devices. Also, hearing loss is common in older people, and an individual suffering from hearing loss is often at a distinct disability when interacting with his or her surroundings. And design responses to the aging population are evident all around. Tools and utensils with larger handles, changes in the car to increase the elevation of seats and provide easier access and egress, as well as um, many other accommodations. Uh, so the changes in visual ability also suggest a number of considerations. The loss of depth perception and vision affect a person's ability to see a small change in grade on the walkway surface. It might be prudent to provide visual signs such as a change in shade or texture at such breaks in grade. So walking is the most common exercise activity for older Americans and for younger ones too, followed by exercising with equipment of some sort, fishing, camping, golf, and swimming. So in the stage one integrated walk network, pavement color and texture as well as signage can be employed to assist users with wayfinding and guidance. So there is another chart showing the checklist of physiological changes with age and some design implications. So please refer to that. And the key to successful redesign or adaptation is to maximize access and maintain the quality of the experience. Barriers that restrict users from general access prevent the maximum use of facilities without a corresponding element of enhancement or need for preservation or of quality. So another chart showing minimum path clearances as well as the personal mobility vehicle dimensions. So when we talk about sidewalk design for older adults, and that is in particular relevant when we design an like a 55 plus community. So the design should be based on adults seated in personal mobility vehicles or power scooters. And these low cost wheeled devices um, are likely to become more common in the future, particularly in those communities where people age in place. So that was it for the designing for older population, and we are moving to the next part, and that's design for dogs. So as more of our population moves into urban areas and we take our pets with us, dog parks have become a more common feature in existing and developing communities. And a dog park uh, should be at should be surrounded by a fence 4 to 6 foot tall, and it is considered to be good practice to provide separate areas for small and large dogs. So entrances for dog parks should be a double gate system to reduce the chances of escape or unwanted entrance to the park. And entrance should be toward the center of the long dimension of the park. Here you can see pictures showing that. And the dog park must also consider the pet owner. Shade should be provided in the form of gazebos or pavilions, and seating should be provided throughout the park. To reduce congestion and conflict, sitting areas and watering facilities should not be located near entrances. Restrooms should be provided for the human park users as well. So, and that was it for our chapter 5. Thank you so much for watching. I will see you in chapter 6.